All right, in this video, we're going to take a look at graphs of both position time and velocity time. And a graph has a great story to tell. There's a story, there's a tale wrapped up into every graph. So let's take a look at this graph. This is a position versus time graph. And you can see the position versus time graph has a line like this. So a couple of things about this. This line has a constant slope. It starts at 0, 0, and it ends at the point 8, 8. Okay, so if I were to describe this, I would say the person that's walking starts at the starting point 0, 0, and begins to walk in a positive direction for 8 seconds. They move at a constant speed. I know they move at a constant speed because the slope of this line is constant. Okay, so the reason I know they're walking in the positive direction is because their position is positive. If the line went like this in the negative direction, I would know they were walking in the negative direction. Okay, so from this position time graph, we can come up with the physics definition of velocity. So velocity is simply the slope of a position time graph. And if we look at position time graph, slope is change in y, so it's delta y, over change in x, which is here. Now if we look at this graph, the change in y is from 8 to 0. So from 8 to 0, and it's in meters, so 8, let's do that in black. So 8 meters divided by our change in x, so rise over run, which is 8 to 0 seconds. Notice we're always starting from the points out here. So when I did the change in y, I started from 8 and went back to the initial point on the y-axis, which was 0. So you wouldn't do 0 minus 8. So here on the x-axis, it's 8, and then it's 0, so that's a time of 8 seconds. Okay, so this gives us a slope of 1 meter per second, and that is what we define the velocity as for this position time graph. So the equation for the velocity, for average velocity, is the change in the displacement or position over the time. Okay, so this is an equation that will come in quite handy. The velocity is the change in position over the time, right? And the units of this are going to be meters per second. So let's take a look at a couple different position time graphs and talk about what's happening with them. So here is a position versus time graph, and we can see it looks like this. So for this object or person, whatever it is, we see that it starts at 0 and it moves towards 12. So here we see the slope is a positive number. So since the slope is a positive, it's going up, that tells us the velocity is positive. All that means is the object is moving in the positive direction, which we know it is. We can see it's starting at 0 and it's going to positive 12. So maybe we'll define the positive direction as forwards and the negative direction is backwards. But whatever it is, it's moving forwards. And then here, this is interesting. On a position time graph, the straight line tells us that the object has stopped. It is no longer moving. So from 5 seconds to about 9 seconds, it has stopped. And then we see from 9 seconds to 10 seconds, it has a very high negative velocity. Now, how do I know that it's in high negative velocity? Well, I can compare this line to this line. And I see the slope of this line is much less than the slope of this line. So since this slope is less, that means this velocity is less, and it makes sense. This, from 0 to 5 seconds, it covered 12 meters, right? So it went 12 meters in 5 seconds, so the velocity is 12 over 5. Here, it went, in 1 second, it went 12 meters. So here, the velocity is 12 over 1, which is a much greater number. We also see the slope is negative, which tells us the object is moving in the negative direction. Now, if I were to ask you, So when I was referring to the velocity at any point around here, this is what is known as the instantaneous. Let's do that. That's what's known as the instantaneous velocity. It's the velocity at any point on a graph. Okay? However, if I were to ask you what's the average velocity is the total displacement over time. It's not just a snapshot somewhere along the line. So the total displacement of this object, well, it starts at 0 and it ends at 0. So the total displacement is 0. So the actual velocity, the average velocity of this car, would actually be considered 0. So now let's look at the connection between a position time graph and a velocity time graph. So let's watch Moving Man here and see what he does. So when Moving Man's going here, we're going to start Moving Man at and we have his position versus time graph. So here's position versus time on the x-axis, and here's his velocity versus time. So he's going to start at the position of 7.2 meters. So it's positive 7.2. So on this graph, positive means to the right. And let's watch what he does, and we'll talk about it here. So you can see Moving Man moving to the left, and as he moves to the left, you see that he has a negative position versus time graph. It's not quite constant speed. It's a curved line, which tells us that his speed was changing. It wasn't a constant speed, but we see that he was always moving in the negative direction. He has now stopped, so his position time graph has gone flat. He stopped at about, if we look at this graph, at about -9 meters, which is right where we see him. Now, interestingly, his velocity time graph was a little bit all over the place, but notice it never crosses 0. It's always on the negative side, which tells us he always had a negative velocity, which means he was always moving in the negative direction. In other words, from right to left. Okay? Now, you see here, his position time graph where it's flat, he's not moving, corresponds on the velocity time graph to a velocity of 0. So on a position time graph, not moving looks different than not moving on a velocity time graph, because on a velocity time graph, if you're not moving, you always will come back to the 0, 0 point. Okay, so let's watch a little bit more what Moving Man does. So we know he rests. Now he's walking in the positive direction. We see his displacement is positive. Okay, so what we just saw with Moving Man, as we saw as he moved to the right, first of all, the slope of his position time graph was positive, which tells us he has a positive velocity. And that matches up because down here we see his velocity is on the positive side of the 0 line, right? So that means he has a positive velocity. He was moving in the positive direction, which is this way. We see that his speed's not quite constant here, but it is pretty constant. And because he has a positive velocity, he's heading towards a more positive displacement. He starts at -9. He ends up at, right now, he's at 7.5, which is where he is in the graph. So from -9 to 7.5 is a positive displacement. He therefore has a positive velocity. We now send him back in the negative direction, and we see a negative velocity here, a negative slope. He's heading back to 0, okay? Now, interestingly, with Moving Man, is we can see that he's not quite gotten to the 0 line, so the position time graph never quite gets to 0, but at the same point where he's at 0 on the position time graph, his velocity is not 0. So being at 0 here does not give you a 0 velocity. Again, the only thing that will give you a 0 velocity is not moving, which the only time he did that when he was right here. Okay, and we again see a negative slope to his position time graph, which told us he was moving in the negative direction again. And we'll finish this out. Let's see. Right, he's going back and forth now. he's moving just back and forth, and we can see his position time graph. Now he's in the negative direction, so we see a negative slope, a negative velocity, and that's it. All right, so with the moving man, hopefully you're able to see a little bit more of the connection between a position time graph and a velocity time graph, okay? If you have any questions, bring them to class. And always remember, physics is fun.